Hello and welcome back to How to Get an HD in Business Modeling. I'm Reza and today we're looking at a question from chapter 9. Question 17 says, the owner of an Exin Health Club franchise believes that the average age of her members is under 55 years. To test this, a random sample of 30 was selected. The following sample data are the age of the sampled individuals. So we got 30 observations here. Part A says state the appropriate null and alternative hypothesis. Okay, the first part is quite straightforward. We are dealing with a mu which is 55, yeah, that's the mu. And if you read the question again, the owner believes that the age of her members is under 55 years. So we're dealing with the directional hypothesis thing, okay? Because it says under 55. So it's a one-tail test, and because the mu is less than 55, it's as a left-tail test. So this information you get from the question. So when we have a directional test, you need to write HO and HA. When you have a directional test, you start with HA. So mu, it says less than 55. We put less than 55 here. Your null hypothesis would be opposite of what you've written and the alternative, so it would be larger or than equal to 55. So that's the null and alternative hypothesis that the question is asking you to develop. Now look at part B. Part B says use the test statistic. Use the test statistic approach to test the null hypothesis with alpha 0.01. So part B says alpha is 0.01. Now if I draw the distribution, let's summarize what we know, what we've got from the question. That's 0. And it says, we know that's a directional as a left tail test because of this alternative. It's a one tail test and it's a left tail test. So alpha should be here on the left tail. So if I change the color, show the area, that's area is your rejection area. Remember that? And it's only 1%. Therefore, this area from mean to the point is 0.49. Now, am I dealing with a t-test or a z-test? It talks about the sample. I don't have any information about population standard deviation. What I get from this is it would be a mean and standard deviation of a sample. Therefore, I'm dealing with a t-value. Okay, let's calculate the values that I have. We said mu is equal to 50. I just rewrite this. Mu is 55. So sample size is 30. If I enter the values into the calculator and be on a stat 0 mode, enter the values and calculate x bar, which is the mean, and s, which is sample standard deviation, I should be able to get these two values easily. X bar would be 52.0667. Please enter the values into your calculator and calculate x bar and s to see whether you get the same result as I did. S is 17.1885. Remember, we always go with 4 decimal places in this unit. Okay. Now, I need to get the value here. The value here is your t critical. Using this information, I would be able to find, so this information would give me t stat. Then I can compare t stat and t critical. How to get T critical? T critical comes from the table. For that, remember you need to have degrees of freedom. Degrees of freedom is n minus 1, which is 30 minus 1, 29. I go to the table. This is T distribution table. I'm dealing with the hypothesis testing, and I'm dealing with the one-tail hypothesis testing, okay? And 1%. So that's the column I'm interested in. Degrees of freedom 29. 29 is here. And there is 1% one-tail. That would be equal to 2.462. So that would give me T critical as 2.462. Be careful, because I draw the distribution, I know that T is on the left side of the mean, so on the negative side, so T should be minus 2.462. Be very careful when you find the value. Okay, now I have T critical value. Can I find T stat? T stat formula is equal to x bar minus mu over S over square root of n. X bar, you got it from the your calculator, 52.0667 minus 55 over 17.1885 over square root of 30. If you solve this, you should get a negative value, because 55 is larger and it has a negative sign, 0.9347. Plug in the values into the calculator and you should get minus 0.9347. Okay, T critical here was minus 2.462. My T stat, if I use a different color, is somewhere here. So T stat is minus 0.9347. We said if any value is here in the red area, we would reject the null hypothesis. If the values are in this area, we are in the non-rejection area, so we don't reject the null hypothesis. So how we can conclude that? We can say, this is quite important, the interpretation is quite important, always carries mark, whether it's in the assignment or in the exam. So you can say T stat is larger than T critical, which was minus 0.9347, was larger than minus 2.462. Therefore, we are not in the non-rejection area. Therefore, we do not reject the null hypothesis. So what was the null hypothesis? Null hypothesis was telling you the average population age of this club is 55 years old or above. We do not have enough evidence to reject the null. Therefore, potentially the average age would be above 55. Okay, so be careful how to read the question. It's very important to draw the distribution so you can identify the location of this critical value, or if you have a Z critical value, the location of Z critical value, and then you can identify the rejection and non-rejection area. So that's your rejection area, and the remaining white area is your non-rejection area. Be careful that you need to mention all of this in your solutions in the exam. Thanks for listening. See you in the next video.